Okay, well, let me just say a couple of things before we get started. First of all, for those of you who are here now, welcome to our Building Environmental Climate Literacy Professional Development Series. This is, I'm not sure what the 8th of these small workshops that we've put on, and there are 3 more left that you can sign up for. And if you attend 10 hours worth of workshops, you can get 1 CEU credit from Dominican. It costs $55. And you just contact Corinne at CRS and she will set you up for that. So if that's something that interests you, if you're not interested, we will also send you a certificate. All attendees will get a certificate of attendance for this in case that's useful as well. So I want to make sure that we have as much time as possible for Jessica to introduce this wonderful, wonderful new website that has just been released. It's been a long time coming, but it's full of many, many rich, wonderful resources. And Jessica is an extremely knowledgeable scientist, earth scientist, and life scientist. So the video and slides for this session will be available after the session on the CRS website. So if you missed something and want to go back and reference it, it'll be there. Or if you know somebody who might be interested in it, you can send them there also to look at these resources. So with that said, I think there's really not much more that I need to say. I'm going to introduce Dr. Jessica Bean from UC Berkeley's Museum of Paleontology. And take it away, Jessica.
Thanks so much, Betsy. I'm so glad you invited me to present to this group. So thanks for having me. So yes, for a number of years now, I've been working on a project called Understanding Global Change, and I'll explain more about what that means and share with you, especially a lot of the practices, the teaching practices that we use as part of our program, and also the new online resources that we have. And I just want to highlight up front here that there are 3 main components to our resource that we've developed to help teach global change across the curriculum. So again, to really weave in not just climate change, but anything related to how and why the world changes around us across science curriculum, across grade levels. So what we've developed is a conceptual framework that helps you do that. It helps you make those types of connections across the year. We've developed tools for constructing explanatory Earth system models so that students can show evidence of their thinking, make their thinking visible. And then we've also designed a set of resources that really helps educators take that step to design units for themselves, for their students, to be responsive to NGSS, and also integrate this idea of Earth systems and global change throughout the curriculum. So these are kind of the 3 core components, and I'm going to show you pieces of those today. And just to give you a quick overview of the goals of the Global Change Project, I mean, we're really trying to design materials and use practices informed by science education research that helps, educators and students really think about the Earth as this dynamic, interconnected system, that you don't think about things or learn about things in isolation, but how is all of the world connected, and how do these parts relate to each other? So really digging into systems thinking, of course, which is one of our core our cross-cutting concepts within the NGSS. And then how do we explore the interdisciplinary causes of and solutions to global changes? We're facing a lot of changes, especially in the state of California, related to climate change and fire risk and sea level rise. And how do we understand and also be hopeful and find resilient paths forward? And really make thinking visible. That's my third point here. And that's for teachers to be able to be transparent about what they're doing and why we're doing it and how we're teaching it. And also for students to really be able to share what they know and leverage their prior knowledge, and also show others what they know. So that it's not a mystery about what your students are thinking or what they're learning, and they can really be a community of young scientists learning together and use those practices efficiently. So I just want to say really quickly, there are a lot of collaborators across the country who've worked on this project. So you might have seen some of these resources in other places. And I do want to call out today that we're using data from the River Otter Ecology Project, which is actually a local project based in Marin County that is all about understanding and collecting data about local river otters here in California. And as I mentioned, we work across the country. We have ongoing collaborations with really large school districts on both coasts and some places in the middle. And so we're really excited to continue this work and our reach. And of course, again, as I've said, a lot of our work is about being responsive to the NGSS and leveraging all of the great resources that are out there to help us teach and support the implementation of the NGSS standards. So these are the 3 standards that I pulled out that I think are very relevant to the work we're going to be doing here today together, from middle school all the way down to 3rd grade. You can also go to high school, but these are the 3 that I picked out about constructing arguments to really understand how ecosystems changes, physical or biological components of an ecosystem change over time and affect populations, or develop a model to understand the spheres and how all of those interact, which of course relate to the components of ecosystems and biological populations, and then constructing an argument with evidence that in a particular habitat, some organisms survive well, some survive less well, and some cannot survive at all. That's the 3rd grade standard. So you can see that these are interrelated standards, and you can find connections across them. But these are 3 that are relevant to the work we're going to do here today. So today I'm going to talk a little bit more about the teaching practices that we use in the Understanding Global Change project, but more I want you to experience them. So we are going to enter into learner mode. You'll see the color of the slides actually change color to blue when we start talking about river otters as a local phenomenon for exploration of global change topics. Then I'm going to give you a brief introduction back in sort of adult teacher mode. I'll show you the framework and some of the other system modeling tools that were built as part of the Understanding Global Change project, and I'll give you a very quick tour of our website that was just released in the last couple of weeks. So today we're going to be focusing on these 2 science and engineering practices, asking questions and defining problems, and also developing and using models. And I just want to point out that there are 3 primary shifts that we're trying to focus on within NGSS. That shift from just learning about facts to actually constructing knowledge and explanations of the world around us, and thinking about components and relationships and interactions, and really engaging all students in figuring things out, engaging in those science and engineering practices throughout instruction, and going from rote to meaningful use of those practices. So not just following steps, but really understanding why we're doing what we're doing and the purpose behind them, and helping students think about how they would make decisions to answer scientific questions or solve problems. And so that's what we're going to engage in today. And a lot of the practices I'm highlighting come out of various bodies of work, and again, in science education research, but the 2 I'll highlight here are Next Gen Storylines out of Northwestern and Ambitious Science Teaching from the University of Washington. I can't say enough awesome things about Ambitious Science Teaching. It's definitely one of my favorite books. So the idea is that you're using practices that leverage discussion and explanatory modeling that really provides opportunities for student thinking, making that thinking public, so that those ideas can become a resource for each other, so that people can build off of each other and their thinking. Again, like what happens in the scientific community. That's my formal training is in science. And so the idea is, how do we engage students as young scientists? And then how do we help teachers realize who's silent, who's not engaging, or who haven't figured out how to engage yet? And really have that opportunity to practice scientific ideas in language, that the language isn't useful unless you're using it and it's relevant. So we need to practice and be able to have those opportunities. And so the learning experience that we're going to have today is anchored around a phenomenon. And an anchoring phenomenon is a puzzling event or process whose full explanation requires a wide range of science ideas to be coordinated with one another and with evidence. So just really quickly, these are things that cannot be Googled or have a very simple yes or no question. They're often much more complex than that and require synthesizing ideas over time. And so often we're talking about, at least a couple of weeks worth of instruction that will lead to the development of a full explanation of a phenomenon. And the role of the instructor is to create the opportunities for that kind of learning and thinking and what we call sense making every day, so that students are putting the pieces together and constructing that knowledge collaboratively within a classroom and individually for themselves. And why would we use an anchoring phenomenon? Because we know that everyone really, learns best when content is embedded, it's contextualized, there's a purpose to it, there's a problem or an event or a process that we're trying to explain. Hopefully it's connected to something in your everyday lives or maybe your interests, and that students are able to revise their ideas, that they can learn over time, and that's okay. We're not just looking for right answers off the bat, but that we're trying to increase the depth of our thinking over time, and that really that we can, you know, be responsive to new evidence and information and get feedback from others over time, and that's when learning again can really deepen and become meaningful, is when we have those opportunities. And again, that teachers aren't necessarily just, you know, a place to provide answers, but it's an opportunity to help students talk and reason. And so these are this is the talk taxonomy from Ambitious Science Teaching, and students and teachers, and especially students among each others, are you know, able to have these conversations about scientific topics. So teachers are there to sort of, you know, press students for more examples or justification of their claims, that, you know, that you follow up about what students are thinking, open up crosstalk among students, and also waiting, being patient to see what the responses will be, and also revoicing, you know, to say, okay, I think I hear this, does everyone agree? Or how do we express this differently? And also focusing, asking for clarification at times. So these are talk moves that hopefully you'll see me use today, and you'll see the context in which they're used. So we're going to jump now into learner mode. So that was just a brief introduction again to the practices that we are using today. And so we're going to be exploring river otters as an anchoring phenomenon. And if you were at Sagit's workshop a couple weeks ago, you saw something fairly similar that was especially appropriate for younger learners, because we've been collaborating in some work that we're doing with the Marin County Office of Education. And so today we're using a lot of practices that are sort of upper elementary through high school that you can use with your students. All right, so now as adult learners using your full scientific knowledge, I'd like you to just share what you already know about river otters, and write down on your own piece of paper. Just take a couple, okay, let's take a minute to write down your ideas. What do you already know about river otters? And if you'd like to share some of your ideas in the chat, that's awesome. Okay, so I'm seeing Tracy saying they like water and they're curious. They're cute, says Jen. Do we all agree that they're cute? Is that an easy one to agree on? Yep. They're endemic to North America. Joe, would you like to explain more about what you mean by endemic?
They are native.
They're native
to North America.
Okay, great. And Clara says, if they're anything like sea otters, they are keystone species. Interesting. Clara, can you clarify what's a keystone species? Does anyone have any, what do they think of when they hear the phrase keystone species?
Let's see, a species so important to its environment that its removal would bring catastrophic disaster to a habitat. Or you could say like a species, group of similar looking things capable of making viable offspring that in its existence creates, I don't know, ecosystem niches for other organisms.
Oh, interesting. So Clara said that it's a species that plays a vital role in a certain ecosystem. Does that align with what you were thinking, Joe?
Yes.
Yeah.
I like to also show my students what the keystone is actually in terms of masonry.
Okay. Yeah. Yeah. Do you want to explain what that is?
It's like the thing on the top that kind of holds the archway on top, the last little stone that goes in.
Yep.
Yeah, well, if you remove it, then the archway or doorway would collapse.
Interesting. Yeah.
And I like to use that as the distinction between keystone species and foundation species.
Interesting. Does anyone else use that visual? with their students? Okay, great. But I think what we're all hearing is that they're vital. They with like, so Clara is also saying that sea otters and urchins and kelp, and without otters, the kelp decreases, which has a ripple effect through the ecosystem. So that's an example of a potential keystone species because it's vital and plays a role. And Joe's asking, sea otters are bigger than one thinks. So maybe, but like about, I don't know if you're referring to their size or their role, but we have some questions. Yeah, and then Clara's saying, I don't know if they have the same role. And then Jen's saying, aren't these river otters? So yes, so we are talking about river otters, but these are great ideas. And again, you're using your prior knowledge and you're asking questions based on what you already know, and maybe you know something about sea otters. And so this is great. So thank you for sharing your ideas. So what I want to share with you today is I've been really curious about river otters for a long time. Actually, I remember seeing them kayaking. I grew up in Sonoma County up here. And it was interesting because I was looking at this range map that was created in 1995 by the California Department of Fish and Game. And so what do you notice about this range map that I'm showing? Or what do you wonder about what this range map is telling us? So you can feel free to unmute yourself or put it in the chat.
Let's see, I would say initially, wherever you find highly dense populated, or basically areas where there's lots of people, that's not where they are.
Okay, interesting. So where do you think there are highly dense populated areas of people? Where are those areas that you know of?
Well, this one, well, we're in the Bay Area, so.
The Bay Area, okay. So like around here?
Yeah, around the Mermaid, yeah.
Around here, okay. Yep, so Terry's saying more common in the north. Tracy's saying Sac and San Joaquin rivers, so up through here. Anyone have any other wonderings or thoughts based on this map? Jen's asking, are they still in all of those areas? It's a great question. Is the change in temperature driving their populations north? Interesting. Or smaller populations? Okay, these are great questions. So now I just want to give you a little more information, because what we found is that there are actually some really cool recent observations that have been made in areas that are outside of this range. So actually what I'm going to show you right now in a second is actually a video that was taken out near Point Reyes of some otters using a camera that was installed out at Point Reyes. So let's see if this will work. And hopefully you can hear it too. Give me a thumbs up if you can hear it, because I love the sounds. Cool. All right, what do you guys think? Like Tracy said, they're curious. Yep, how fun. Yep, I agree. So Clara's asking, what are river otters? Okay, so hold on to your questions. So what I'd love for you to do now is start recording those questions, because I see so many questions coming in. So what I want you to do is go to this Jamboard, and Betsy just put the, thank you Betsy, put the link to the Jamboard in the chat, or you can enter it, the tiny URL. And what we'd like you to do is put one question on each sticky note. And I'll show you how to do that in a second if you've never used Jamboard before. And when you place your sticky on the Jamboard, think about where it can go, maybe near some other similar questions that people are asking. And start thinking about what those categories of questions might be. And be prepared to share your ideas with the whole group. So just really quickly, for those of you who may not have seen Jamboard before, Jamboard is a free tool on Google, in Google Suite. You have to kind of scroll down sometimes in your account to see it. It's a digital whiteboard that you can use for collaboration, both synchronous or asynchronous. And I created this Jamboard so I can see all the stuff that's going on while you're working on it. And you can actually save the Jamboards as images and PDFs. The work is anonymous, but you could initial your stickies if you want students to be held accountable. Or you could ask people to use different color stickies or pens is one way of doing it. Okay, so to make a sticky, you're going to use this tool that's on the left side. And then I'm going to switch over to the Jamboard so that we can watch what's going on. Was everyone able to click on that Jamboard link? Is that working? Okay. Okay, so now can you see my screen with the, all right, there we are. Oh.
Oh my gosh.
All right, so it's going to give you like 3 or 4 minutes, maybe let's do 3 minutes because we're a little short on time to do this, to write down those questions. I saw a lot of them in the chat, so I know there are more. We have questions about what do they eat? How has their population changed in the last 50 years? Do they go in the ocean too? Some more questions coming in. So remember, think about how you might group your question now with those other questions that are already there. Yeah, do they have commercial value? The population's thriving. Are they threatened? Are they endangered? Habitat encroachment. Otter predators. Why should we care about the river otters? Good question. Have human activities impacted their population? Nice, I see a lot of you are grouping them. All right. So if we had more time today, what we would be doing is then coming up with names for the categories that we're forming, and we would have a big group discussion and think about what are the big questions that we have that come out of, that we can combine or summarize in a few questions. But these are great. What would happen if the river otters didn't exist? Great questions. All right. Well, thank you for your participation. Head back. Okay, let me, sorry, I'm having trouble getting back to my other screen. I'm just going to stop share for a sec. All right. Okay, so again, what we did was we categorized a lot of our questions, and here's some other example questions, again, very similar to yours, like what's changed here, how many are there, you know, what do they need, what do otters need to survive, or do they have economic value, how do they impact other organisms, So again, we would recap your questions if we had a little more time. And then really, if you synthesize all of these questions together, we usually come up with this driving question of, so why are river otters? Why are they present now in Marin? And really what we also know, which I'll tell you, is that they used to be here and now they're coming back, which is really fascinating. So just in the last 40 years, we've been seeing a lot more of them around. Let me just ask you for like 2 seconds to write down some ideas about why do you think that might be? Why might river otters be returning now to the Bay Area and to Sonoma and Marin counties just in the last 40 years? Feel free to unmute yourselves if you want to share out your thoughts.
Maybe there's a group of people that have suddenly taken interest in them and have done conservation.
Oh, interesting. So maybe something having to do with conservation. Does anyone want to add on to that idea? Jen saying, have their populations been affected by the pandemic? Interesting. Jen, what led you to ask that question? I'm curious.
I don't know, but I do a lot of these workshops and it always seems to, it just factors into everything. I don't know. And it'd just be interesting to know because you do see less pollution, etc. So I was just wondering.
Interesting. Yeah. So something about pollution, and maybe that is related to what was said about conservation earlier. Seeing restoration of waterways. Water travel, accessibility, food sources, other changes. Okay. So these are awesome ideas and they all might be related to now. This is a data set I want to share with you. This represents observations of otters that have happened in the last, I think this is the last 7 years. So the yellow dots are observations of otters that were seen alive. And again, this is a part of the River Otter Ecology Project that's based in Marin County. The red X's are observations of dead otters. And then the blue ones are possible sightings. We're not certain based on where they were seen and the amount of data available. We weren't certain that these were otters. So does anyone have any noticings or wonders? Oh, Jen's asking, how were they observed? That's a great question. How do we think they might have been observed? Oh, Jen's saying maybe cameras. Anyone else? How might these have been observed? I will say that anyone can actually contribute to this data set. So how might, yeah, volunteers, Jen's saying volunteers.
Park naturalists.
Park naturalists, yep. So maybe experts who are in the field, or rafters or kayakers, Terry's saying. Drones, Tamara's saying, awesome. Observation, citizen science, yep. So my understanding is that it's all of the above. But again, it's great to have you and your students brainstorm, how would you build a data set like this? How would these observations be made over time? And so I'd like you to just think about this data set and then also this information on this map. So this is showing population density in the Bay Area and where we live now. So this is from 2010, showing where development has happened and where development will happen. And so think about that the darker red is higher, denser areas, right? And the green is lesser, less populated areas. So using those two pieces of information that you have now, what I'd like for you to do is actually construct a model using all of these ideas about why are otters now returning to, again, if you're somewhere else in the greater Bay Area, you could use that. We've been focusing our work with Marin County Office of Ed, so we've been using Marin as the focal point, but why are these otters returning to the Bay Area? So we'd love for you to talk and agree on some things before you start writing. And we're gonna put you into a couple of breakout rooms. We'd like you to use those ideas that you've shared to construct a model. And again, using words, diagrams, arrows, whatever you want. And think about what maybe you can see easily, observe, and what you can't see. And again, there are many ways to communicate your ideas, and there are no wrong answers at this point, because we are just learning about otters. And so for the, again, for the purposes of this model, there, you know, don't worry, the idea is that we're going to improve your ideas over time. And each person could use a different color pen or sticky note so we could see that everyone is contributing. Write down each question you have. You guys have a lot of awesome questions. So if you think of more, please record them on your Jamboard, your model Jamboard, and put them on a sticky note. And I'm going to give you about, let's say 5 minutes to work on your models. And in a classroom, I just want to say I would give at least 30 minutes to an hour to do this kind of activity with students as they do it collaboratively.
Jessica,
yeah.
Somebody, Jen is asking if we can see the two maps again.
Yeah, and they are on the Jamboard that I'm going to give you. So if you go to the last page of the Jamboard link, so Betsy, if you want to put that link in, that's great. So this is what you'll see on the Jamboard. When you open it up, this is group 1. So there are going to be 2 groups. So if you're assigned to breakout group 1, you'll go to group 1. If you're in breakout room 2, you'll go to the second page, and you can click the pages up here at the top. This is the arrow. And if you click all the way to the back, it'll take you back to those data sets. Both those maps are available to you to use as resources. And again, these are the different controls. So this is the draw, the pen, there's an eraser. You can select things. There's the sticky note, which you already used. You can import images. There's a shape tool. There's a text box. So I would guess that most of you are probably going to want to use the drawing tool and maybe making more stickies. And then what I've also provided for you over here are some icons and visuals that you can use. So here's a picture of an otter, and you can actually duplicate this image if you want to make multiple otters across your Jamboard. Some little water ripple lines, some plants, things that we already saw in that video. And then a lot of the questions and thoughts that you came up with really had to do with maybe, again, human activities, building cities, where we live, potentially fishing and hunting, right? Or do they have commercial value? What's going on with the otters as it relates to those activities? And then also pollutants and waste, right? And the health of our ecosystem. So you can use these 3 icons to help connect to the bigger ideas. And what we did was divide your Jamboard up into 40 years ago, what was happening 40 years ago, and now what's happening today that would lead to these changes and the return of the river otters. So is everyone able to get into the Jamboard? Is there any problem with that? So as I mentioned, use these 3 big ideas as you see appropriate. I also want to point out that you can zoom in really far. All the instructions are also up at the top of the Jamboard, and you can zoom in using this zoom tool, and it'll make the frame much bigger so everything can be read, and you have a lot of space there even if it doesn't look like it. So use the space. And yeah, so now I'm going to send you off into breakout rooms. Okay, so, and if you're in breakout room 1, if you just want to stay here in the main room since we're recording, that would be awesome, if you're okay with that. So that's Clara, Joe, and Tracy. Are you okay with staying in this main room? Seeing, yes, sure. Okay, great. So I'm going to open up breakout room 2. So Jen, Tamara, and Terry, go ahead and join breakout room 2. Cool. All right.
So you can unmute yourselves and just have a conversation. And
yeah, and I'm going to share your Jamboard so that it's on the big screen, and you should feel free to work and add to it. I'm just going to go check on the other breakout room and make sure that they're doing okay. I'll be right back.
What do you guys think?
Hi, you guys doing okay?
Mm-hmm.
Okay, good. Let me know if you have any questions.
Okay. So, is it lady? Yes, ladies. They're cute. I'm from LA, so I'm not familiar with the otters at all, but they're really interesting.
And we know that there are other species you could probably be using in LA, certainly.
but I like the otters.
Yeah, the otters are very cool. And you could even be, you know, you can be using very similar questions and concepts for like sea otters and mountain lions and bobcats and all sorts of cool things that I know you have down there too. So,
Be sure.
yeah. But everyone was able to get into the Jamboard?
I think so.
Okay.
Tamara, are you still driving?
No. I don't think that would work very good.
Didn't think so.
Yeah, I
Yeah,
don't
go
know Jamboard as much as you guys, so I don't know how to make a copy, and you're doing quick work of it. So
all you do is you click on it. If you click on it, the 3 dots come up, and you can go to the 3 dots and click on that, and then it makes a copy.
You can also just use the traditional copy paste command on your keyboard.
Okay. I didn't do
Either way works totally fine. Yeah.
out. Sorry, my dog doesn't like it when I laugh, so he always freaks out. I don't know why. Okay, so building cities. Where should we put building cities, Terry? You're muted. You have to unmute. Do you know how to unmute?
Let's see if I can unmute Terry. Yep.
You have to go back to the Zoom, Terry, and click on, you know, where the Zoom is.
Yeah, I can't unmute you, Terry. Sorry.
Okay, my screen it's not doing anything. It's like just loading and loading. So
Oh no.
I'm in the boonies and we don't get very good.
That's hard.
One of you can share your screen. Does one of you want to share your screen? I can give you access to that.
Yeah.
Who's able to share? Jen?
Yeah.
Okay.
Okay, so now
there you go. Perfect.
I'm doing other stuff in the back.
I can see it, but I can't.
So if yours isn't loading, then tell.
Well, you look at habitat, food, and shelter, right? Those 3 things.
Makes sense.
So if they're coming back, that means probably the pollution and their food source has come back, right? Or we're not exploiting them, like hunting them as much.
So,
That's my initial thought.
so you're putting in lots of fishing and hunting on the left and less fishing and hunting on the right.
Yeah, maybe. Yeah, so we restricted it. Yeah.
Right.
So it's just Marin County, right? So I feel like Marin County has not experienced giant population growth. I could be wrong though. I'm not 100% sure in terms of people.
Well, that's a great question. If you want to write that one down, I think that's a great question.
I can do a post-it.
But it looks like you're using all of the ideas that are there. Does anyone else? What do other people think about population or building cities?
Well, it's kind of interesting. They're on the coast. There's more sightings on the coast. There's high densities along the edge of the bay, at the top of the bay, on both sides, and those areas are populated.
Yep.
So they don't seem to be avoiding populated areas, I guess I would say.
Yeah.
If I look at the map.
Interesting. So what does that tell you about what otters need or what they're looking for in a habitat?
Well, that they don't need to not be around humans.
Yeah.
Which may be related to the hunting and fishing as well. But building, so we know people aren't the issue. Cities may be.
So there must be something else that shifted or changed aside from just the presence of people.
What about pollutants and waste? What do we think is happening with pollutants and waste?
It's
Shoot.
No, yeah, I guess that's dependent on. I don't think there has been any major regulation on pollution in the past 40 years. But maybe with a clean water. I don't know when the last Clean Water Act was enforced.
Hmm.
Mm,
Again, that's a great question, is when did that happen and what were those changes that might be relevant?
oh, I like that one about algal blooms. I didn't think about that. Yeah, there might be some sort of culture unification kind of issues or climate change probably might have. Yeah, they're saying that the redwoods are doing much better than they used to because of climate change, actually, because that's the immediate effect because the more CO2 in the atmosphere. So maybe with more redwoods creates cooler streams. Maybe otters do better in cooler waters.
So maybe temperature is a part of the story, and there's something about the health of the streams or the way the streams are flowing. What do we think about that?
Since I said it, I thought it was a great idea.
But you're thinking about all these different parts, right? You're thinking about the trees and the water and the temperature. So I would write down all those parts, right? Like those are things you might want to consider as part of this model.
Oh, this model is getting complex.
Yeah.
Why can't the world just be simpler? Just be, okay.
Because it's not. Okay, I'm gonna go to the other breakout room really quickly, and then I'm gonna bring everyone back.
The end of wanting their pelts. I mean, maybe that's 100 years ago.
Hey
Yeah,
guys.
maybe. Hi.
So just like a 30-second warning, and then I'm gonna call everyone back. So,
What do you
but
think?
this looks great. This is great, and you'll be able to talk a little bit about what you created here. It looks
Okay.
awesome. Yeah,
Pollutants and waste, unregulated, maybe. Yeah.
yeah.
Oh, where here? Okay.
Yeah. You don't even have to type it with 30 seconds, whatever.
Oh, it's okay. Go ahead. You have time.
Okay.
Regulated. Got it.
Thank you for being our typist. I'm like, I can't even get into it with you being the one on the front so we could all see it. Thank you though.
Oh, well, I'm glad that it worked out. Yeah, I like doing this. I've been doing it for a little while. I started Jamboard this summer.
Right? Yeah, that's great.
I use the word audits, but maybe that's not a maybe there's a
Census?
term for that.
I think you mean census.
Census? Accuracy of
That's
census.
the word we use if you do a census.
All
of a
right.
population.
Is everyone back? So how'd that go? So Joe said something interesting when I was in the group. Joe, do you want to share your thought about the complexity of this?
I said a lot of things. Most of it pretty garbage, but
No wrong answers.
Which one did I say?
So
the world's complex, and why can't it be simpler?
Yeah,
Just general complaining about how difficult this is.
Well,
Yeah.
Joe was talking about, how is this connected to the ecosystem? You were talking about the redwoods and the streams and the temperature, and so just lots of great ideas and questions.
Thank you.
So from all of you. So again, thank you for participating. So group one, do you just want to say something really quickly about what you created? Or Betsy, did you want to say something?
Is group 2 back yet?
Yes, group 2's back, right? Yep, Jen and Smart. Yep, I think we have everyone back.
Yep, we're back.
Okay.
Yeah.
What would we say about our model here? We've talked a lot about the habitat and how the habitat had changed, but the biggest impact we thought was probably hunting and fishing that we felt confident about. There was a big change that way that would take the pressure off of the otters and allow them to move into areas that are more inhabited by humans, which is what we saw on the map.
And so
that was a pattern that we saw and tried to portray in the...
And hunting of the otters themselves.
Right.
Was it you're focusing on? Nice.
That was one thing that we saw in there.
Anything else? Joe, do you want to add to that? or Clara?
I'm trying to.
There were just too many variables, and I'm just kind of thinking off the top of my head is if this is supposed to be a model, what is it modeling? Like, I guess it's supposed to model like explaining how the populations of otters that came back. But if it's like models are only sometimes too much information, kind of I don't know, does the model injustice or something.
Yeah, so how do you break it down, right? There are a lot of pieces. So how do you represent that complexity?
I think modeling, you get to choose its parameters and you have to start small and then you build upon it. You know, you decide the system.
Yeah, so group 2, do you want to share what your thoughts were in the way that you structured your model?
I liked how the group 1 did it with where they did extra otters or extra things. That was cool to show the amounts. Why is your otter upside down though? I don't, for group 1, if you go back to group 1, why is it upside down? I don't understand.
They had negative numbers, like negative 12.
Oh, I get it
No,
now.
I'm joking.
No, that makes sense. Okay, so we just laid it out, and less populations, less protections, less laws. It probably wasn't as regulated, increased, more recreational maybe now. And some, but it's probably less. I think that California's cleaned up a lot in the last 40 years. And we were wondering about the fires too and the impacts.
Oh, interesting. So does anyone want to expand on the idea? What do we mean by cleaned up?
By cleaned up?
Yeah.
Oh, I think that a lot of, I don't know for sure, I'm not originally from California, but from what I understand, it sounds like that the pollution is a lot better nowadays than it used to be.
Interesting. Oh, go ahead, Jen.
No, that's it.
Does anyone want to expand? What do we mean by pollution, or what are those sources of pollution that we might be talking about?
Just like how many laws and regulations there are now, but then the flip side of that is how many pollutants and waste went in creating the modern society that we have, and how long those actually live. I don't know if they have a half-life, but whatever you would call it. So.
Oh, interesting. So you're thinking not just about what's there, but also how long it's there. So that's a really great question. Yeah. So how long, do things stay in the system?
Well, we have a lot of mercury too in our rivers, and now it's covered over a little bit more than it used to be. So it's not leaking quite as much. But if they keep building on it, and then it just scrapes it up. So
mercury might be a source of pollution that we are being more aware of, how it might be entering the system. Well, these are all great ideas. So again, the idea here is that, of course, you're just leveraging your prior knowledge and thinking about what otters need to survive, right? And thinking about these different parameters. And yes, it's complex, but the reality is we started with something that's pretty accessible in the sense that otters weren't here and now they're back, right? Which is pretty awesome. And trying to understand why that might be. The great thing about this phenomenon as well is that it's hopeful, right? Like, this is a hopeful phenomenon. This is about a resilient species and the way that it's actually returned to the region, to our backyards, really. So let me, sorry, I'm having trouble switching between the PowerPoint. Will come up. All right. So again, the idea is just to get your initial thoughts and leverage that prior knowledge into building. Can everyone see the PowerPoint now? Is that working? Okay. So these are just some other examples that I've collected. So we're sort of coming out of learner mode now, and I just want to share with you. These are some other examples I've gotten from other participants and workshops, and we're going to be doing this work in classrooms with teachers this year and actually for the next 2 years, because we were recently awarded a NOAA grant for the Marin County Office of Education. So if you're interested in seeing how this unit continues and how it builds, please check in, and we'd love to share these resources with you. But here are some other ideas about how, again, very much the way some of you were saying, all these different parts, all of these connections, thinking about the temperature, thinking about the otter food source, thinking about regulations around fishing, plastics and waste, all these different things. So again, lots of different ideas that you can explore and connect to this idea of the otters returning to Marin. So again, as I mentioned, these were the 3 standards I pulled out earlier that I mentioned for middle school to 3rd grade. And so how do you break this down? How do you get students to really be thinking about global change and topics like this and putting the pieces together, right? And also, how do we plan for instruction when we're talking about complex phenomena like this? So what we created for the Understanding Global Change project at UC Berkeley is this framework that has 3 primary components. We want to think about the causes of change. What are the things that cause change in the Earth system? Then there are things that are always happening that explain how the world works. And then there are measurable changes in the system that we can track. That's our data, that's our evidence. So I'm going to unpack this just really quickly for you. So again, within the Earth system, how it works, we can think of the 4 spheres, right? And you could use, air, water, life, and earth if you want to use this for younger learners. But the idea is we can talk about things like the water cycle or photosynthesis. These are essential parts of the processes that are always happening, right, over the surface of the Earth. And then if we think about the causes of global change, a lot of the reasons why we see changes today is because of human activities. So we want to break it down into these icons that I gave you, right? So things like pollutants and waste, or building cities, or fishing and hunting, or burning fossil fuels if we're talking about climate change. So these are the major causes of change that then put pressure on the system, right? Things like the water cycle, or photosynthesis, or the way that, evolution, or the way animals interact. And then what we can think about is, now, how do we know that the world changes? Right? Then what's the data, what's the evidence that we can look to? And so what we were looking at today in thinking about the otters is we're thinking about where organisms live, or where can they survive, and what impacts that. And we can also be thinking about things like biodiversity, or things like air temperature, which was even mentioned, or sea level rise in the hydrosphere. Like how we measure these things. We know the world is changing because we have evidence and data that we collect over time that tells us about, again, where things live, or how temperature change, or sea level rise. And the reality is that these are also our phenomena, right? This is the basis for our phenomena, or these measurable, observable things in the world. And so we turn to those measurable changes as sources of inspiration for anchoring phenomena. So we have teachers who use this as a word wall. This is an interactive thing that they build up or break down and make more or less complex over time, and add the key ideas and words that students generate or come up with. Again, I think a lot of your questions were reflective of the icons that I gave you today. So that was why I gave you those. And so you can pick out the ones that students have discussed or mentioned, and then start adding them to the word wall. And this is just to show you the full complexity of this framework. So there are a lot of icons, a lot of concepts. So again, I don't expect you to digest this in the next minute, but the idea is you can break down and build up this diagram at various levels to show all of these different pieces of the Earth system. And so this was developed with a team of scientists and educators to help us understand and think about, what are all those pieces that we need to think about connecting if we're thinking about climate change and global change issues, including, things like the otters. And we have 2 different versions. This is the everyday language version, which is more accessible for younger learners and also for students as they're learning scientific terminology. And then we have sort of a more full version. So an example would be, instead of using ocean circulation, we use the phrase movement of water in the oceans. So the idea is that this framework is a lens through which you can see science content. You can think about all the pieces and all of the connections that you can make by exploring different phenomena. It's also kind of the "you are here" map of your curriculum, where are you going, what do you teach, what do you connect? And so if we had more time, I would ask you to take a closer look at this framework and really think about, what do you address? What do you connect? For example, if you're teaching photosynthesis, or you're teaching about, ecology, species interactions, what other topics are related to that? Are we talking about temperature? Are we talking about the water cycle? Are we talking about biomass and productivity and sunlight, and right? So what are all those pieces that you can relate to each other? And the idea is really that we're moving away from just information, right? This meme has been going around, I think, on the internet lately, but we want to move away from just discrete bits of information, and we want to connect those dots to create knowledge and create transferable knowledge so that people can really understand these concepts and connect them. So we've created these tools, these hands-on learning tools, so that you can actually create your own Earth system models. And this is an example of a model on what we call the Earth scene, which is a laminated board that can be used over and over again. We've also created a way to create these models digitally using these icons to create these visualizations of the Earth system. And you'll have access to these slides, and of course on the website you can download all of these icon sets that allow you to construct those models either on a Jamboard or in person. But you can create these models that represent your thinking about different topics. So here's an example of one that might be related to the otters, again, thinking about fishing and hunting and how species interact and where they can live. This is actually one that you can actually also make them, of course, on different backgrounds. This is actually a picture of Marin, of the Hamilton Wetland Restoration Project. So what happens when we create natural habitats, right, for these organisms to live and to potentially thrive? So we also created this online tool with the help of HHMI Biointeractive that allows you to, drag and drop and draw these arrows and write and annotate your models. And so again, this really gets at that idea of systems and system models, that NGSS cross-cutting concept. And I'm just gonna skip over this really quickly and give you a 1-minute tour of the new website just to show you where to access this. This is our new website, ugc.berkeley.edu. And the website gives you a brief introduction again to the framework, just in the way that, and this Earth scene and these other tools that we've created, just in the way that I did today. We also have these sections around what is global change. So there's a great introduction to global change. So thinking about all the different parts of the Earth system and how they interconnect. And this is a slideshow. It probably takes about 20 minutes to get through. And then we have the infographic, which I showed you, which was the version of the framework with all those icons in it. And then we have pages of information about each of the topics that was in that framework that you saw. So here's a picture of that 101. These are slideshows. This is that infographic, and you can click on any of these topics, and then it'll take you to an informational page about, say, burning of fossil fuels. And then it'll tell you a lot of connections you can make to other parts of the framework, like how is burning of fossil fuels affect the rest of the system? And it'll tell you all about those connections. Same thing for the greenhouse effect, if that's something you're interested or that you teach, and it'll give you example models that you might use to visualize the cause and effect relationships. And so you can look at all these different topics. You can sort by the different spheres on these pages if you just want to look at topics related to the biosphere. Under teaching resources, I mentioned we have ways for planning for instruction. We also have example units and lessons that are already posted. And of course, you can download all of these materials that I showed you today. And great tips on how to use the infographic. Again, here's a word board example, how to identify phenomena from their measurable changes, constructing those models. The example, the unit we have up right now is about sea level rise. It's adaptable for middle school and high school. And it uses a lot of different resources and connects them all with these modeling practices. And so here's some example models from that unit. And then, as I mentioned, there's a whole guide that can help you create your own units by using these steps and thinking about the systems and the connections that you want your students to be able to make. And then just shows you different versions. We have English and Spanish for all of these materials, the downloadable materials, color, black and white, lots of options. And again, as I mentioned, different levels of complexity and different language, everyday language versus the full and complex version. And then this is that modeling tool that you can access under Construct a Model. So you can make your own models, drag and drop. And then I just want to point out that we've also been partnering with the Clean Network, and they've been housing some of our resources over the last couple years. And we're part of this collection of climate literacy and energy awareness materials. And we've been really fortunate to work with a lot of teachers across the country. And I'm just glad that we were able to share these resources with you today. So thank you for your attention and participation, and I can stick around and answer any questions that you might have. Check out our website, follow us on Twitter. We'll make more announcements about workshops and other meetings.
I'd also like to say that Jessica has put these same kinds of things on Jamboard. So if you didn't want to use the interactive that's web-based, you could also put them on Jamboards, and students can do really nice work. You can put a background and you can give the icons, and students can actually make nice models that way. And then the other thing I would say is that what we did today, Jessica introduced the phenomenon, and then we started to work on making a model, but that would be just the first part of it. And you would continue to gather information as you wanted to focus on different questions or standards or different kinds of science content that maybe you want to bring out. You can really focus where you go with the model building on science concepts that you want to highlight. So it's a really flexible tool to use with a phenomenon like that. You could go on populations, you could go on food webs, you could go in any direction that you wanted to take it. And by selecting icons or framing your questions, you can guide the students to explore different topics. And so you would go deeper and deeper, and you would be building in more and more information as you go through. So that was just kind of a taste of how you start to build those kinds of models. Yes. Using this framework and this kind of thinking.
Usually when I do work, sorry, I didn't mean to interrupt you, Betsy. I was going to say, when I do workshops, I usually have 2 full days. So this was a very bite-sized introduction to what the practices look like, the kind of phenomena that we're diving into, and then how we use these tools. And as Betsy said, the idea is that we go deeper and deeper as the hours, as the days progress. And so you're building up your knowledge and revising your models and going through all of that learning experience as your students would in the classroom. And so I do a lot of workshops related to that sea level rise unit that I mentioned. And we're doing a whole series of workshops related to the otters, as I mentioned, in Marin County. And so we're hoping we'll be able to offer those materials more widely in the next year. So, and just one thing that a colleague of mine keeps saying to me is that she really loves how you can, again, sort of similar to what Betsy said, that the modeling can be very bite-sized, right? You can like select the icons that are relevant to the work that you're doing and put them on a Jamboard, and maybe it's just 3 or 4, but then you ask students to make those connections and explain their thinking and make it visible. And then you can make them more and more complex over time as students learn or they revise their connections. And so it just creates a great space for, again, collaborative work and also evidence to you of student thinking.
Any questions, comments, thoughts?
Yeah, this was fantastic, especially, and then I was messing around with the website, and then there was I got to a link which showed like differences, like how do you want to present this information? Do you want a Jamboard? Do you want a PowerPoint? But then I can't find it.
Okay, it's under the, let me go back in my PowerPoint. It's in the teaching resources. So if you go to the teaching home and you go to the teaching resources and then you go to the downloads and it's the icon sets, it'll give you PDFs and also PowerPoint and Jamboard option.
Okay.
Yeah. In both like the original set and everyday language, and I do need to make the Jamboard set for the Spanish. That's one thing that is not live yet. So.
Great, thank you.
Yeah, of course.
And you did notice that you can, or maybe you just said this and I spaced out. You can put your own photograph, so you can build on the scene. There's a really general scene of the world. There. Or you can make the scene something that's right there in your town or in your school or, in California somewhere.
Yeah, let me find that example.
You can make it really connectable to the students.
Yeah, so like here's an example from Marin. So you're thinking about pollutants and waste that might come from the cities, and then we're creating these more natural ecosystems out here through this habitat restoration and thinking about all of that and creating the model on that local scene. So
was there a list of the different topics covered or that have models that are modeled on this website?
So if you go to the sorry, I keep flipping back and forth, all of these examples over here about how the Earth system works, all of these pages have example models on them. So if you go to the atmosphere, and then you'll see the greenhouse effect, and you'll see atmospheric circulation, like those two, or you can just click up here and you'll get the list of all of them. So just click on what is global change and then how the Earth system works. It'll take you right there. Did that help?
Yeah, no, it's good.
Okay, and we will be working on an Earth system model library, or gallery as I like to call it. That's something I'm actually working on for the next phase of the website, because I think it would be great to have all the models in one place to see examples of different models and different topics. So you don't have to scroll through the pages.
Yeah.
Yep, it's a great question. Any other thoughts, comments, questions?
Thank you.
Yeah, thank you. It was really great working
Thanks
with
for
you
coming.
today. Thanks for coming. Please,
Yeah.
again, please follow up, like follow us on Twitter, email me if you have questions or thoughts or interested in future workshops.
So you also do the other one on sea level rise? Is that
Yes.
going to be offered through CTS?
CRS.
We there's no plan for that yet, but Betsy can get back to you about that. Maybe that's something.
We'll twist your arm.
Yeah. We actually also just recorded a session that gives an overview of the sea level rise unit for the, I'm going to get this wrong because they just changed the name, the California Science Educators Association. What are the CASE, not CSTA, but CASE is what they're called now. The California Science Teachers Association. So we might be able to make that video publicly available after the conference has ended, but I'm not certain. But just be in touch, and we can also just keep you updated about sea level rise opportunities. I'm also, all the materials for the in-person version is currently on the website, and we're currently updating the unit to be adaptable for virtual learning. So please just reach out and I can share the current version with you. So.
Do you want to share your email address, or do you want it to go through CRS?
You can just email me directly. That's totally fine. I'll go back to the last slide.
And if you have any questions about UGC, you can direct them to CRS if you lose that contact, because we can forward that or hook you up that way too.
I'll also put it in the chat. All right, anything else I can help with?
I'm just reading Tamara's comment about New Mexico being a natural gas industry area. And they have no global warming because most people don't believe in it.
Oh dear. Well, global warming is real. It's happening. It's a measurable change in the Earth system with lots of evidence.
You have a lot of work to do, Tamara.
Yep. Lots of work to do. We can do it.
No wonder I'm going to be exhausted. No wonder I'm ready.
Yeah.
Well, thank you for what you do. We need you.
Yep. Well, we just come at it from basic science.
Yep.
They'll get the youth. That's where we gotta get it now.
Yep. But that's why those science and engineering practices are so important. We want to know why we know what we know. How do we know what we know, right? It's not just looking at like people, the evidence or the information, but how did we gather that information? Why do we know that? How do we know that the world is warming? So another great resource I'll just throw out there is about understanding science. It's another resource from the Museum of Paleontology, all about the nature and process of science. So thank you all for attending.
I want to just say there are 3 more left that are scheduled. One this Saturday about it's called Greenhouse Earth, and so it'll be about the greenhouse effect, and another one on Thursday the 12th of November called Food Footprints, about food, and then another one on the 14th, and I don't have the information about what that one's about right offhand, but you can look on the CRS website. And the schedule's there, and all the stuff is archived there. So anything that you're interested in, you and you can get information on. Just look at the slide deck if that's what you want to do. I'll just put the link in case you want to take it away.
Great. Thanks, Betsy.
Professor Bean, can I ask kind of a pedagogical question?
Of course.
I covered air circulation in my class, and if I was to give them a blank Jamboard like this, one that at home, so they're just going to Google the answer, and they're going to really want to just move the pieces to wherever, right? Which is fine. I mean, that's they're doing something. I guess the fear here is they're not going to, how much prep time, so in other words, if I gave them a blank Jamboard, they're not going to do anything because they're so limited in the background knowledge, or they have some, but, so I guess my question is, how do you address, when do you insert this model? Is this somewhere at the end, or is this the entry point, or?
This is actually the entry point. You would start by using this modeling practice, but I would also say that you want the basis for that modeling to not be something that, as you mentioned, can be Googled, so, or that is easily explained. And ideally it would be something that kids are gonna wanna explain, right? So maybe something about, what direction does the wind blow in my neighborhood, or what direction does the weather come from? When I see clouds, where do they come from? What direction? So I would give them a question that relates back to understanding atmospheric circulation, but that doesn't allow them to just Google what is atmospheric circulation and create a visual that's, a textbook image of, circulation cells or whatever. I would definitely make it into more of a problem or a question. And then, they could use a map or a diagram of their neighborhood or something, or a picture that they take of their neighborhood, and, they have to put the directions on it, like which one's east and which one's west, and indicate something on it to build that model. So, but that's a great question, because I think a blank page is very intimidating, which is why you'll notice I didn't give you just a blank page, right? I gave you the otters, I gave you some of the key ideas that were related to the questions that you formulated. And sometimes that's what you have to do, is you have to see what are the questions that students would come up with if you ask them a question like, where does our weather come from? Right? And what direction, and how quickly, they might have a lot of questions about that you haven't even thought of. So sometimes you can use their questions as a resource for the kinds of things you can give them on the Jamboard to help them work through the problem and the thinking. Yeah. So, yeah. Does that,
No, that's great.
Yeah.
I was hoping then for a list of these anchoring phenomenon. But I guess I could think of them myself.
There are websites that provide phenomena. There are a lot of them. So I would just Google around. There's one phenomena for NGSS. I would be cautious though, because some of them I would not use as anchoring phenomena, because they're like, for example, I think I saw one that was like a burning candle as a phenomenon. And I'm like, okay, I mean, candles are cool and combustion is cool, but I don't think kids are going to want to talk about a burning candle for 2 weeks. So, let's talk about, I don't know, like a forest fire or a campfire or something that's a little more, has a little more depth and interest behind it. So, but they are some interesting, lists of images that you can use as phenomena.
County of Education in San Diego has an extensive
Yes.
website that lists a lot of information about phenomenon. And
one thing that I've learned too is like use your local, whatever's happening locally. Like I'm up in the mountains, so the bark beetle, you can take off on that.
Yep.
Why is it there? Is it drought? There's drought. It causes, there's more fires because the beetles are killing the trees. So, it's like build what's local, because that's what your kids are going to want to know about. A lot of times they go, oh, I want to know about tigers, but if they learn about mountain lions or whatever's local for you,
yep,
that works.
And it doesn't mean you can't use resources about tigers. I mean, that's the cool thing. You could learn about tigers, but then apply that knowledge back to explaining your mountain lions, right? You should be thinking about how do they, what's happening with tiger populations around the world? Why is that? Okay, now what is that? How is that similar or different than what we think is going on with our mountain lions? So, I see a lot of great resources that are about elephants and other organisms that are in far off places, but it's about bringing it back home, like you're saying, Terry, and relating it back to to something that the students can really connect to. And I just want to echo what Betsy said. I think the thank you for bringing that up. I think the San Diego Department of Education has some really great phenomena resources, examples of phenomena with data sets and explanations. I think it's the best one I've seen out there, to be honest, because it really provides a good launching point for you to help you develop a unit or connect to an existing unit that you have to a good phenomenon.
And
So,
what was that? The San Diego what?
Department.
County Office of Education.
Oh, the opposite of it.
Yeah.
County Office of Education,
Yeah.
yeah, SDCOE. They have a phenomena project, and they had a series of phenomena summits. So they have a lot of resources there.
Yeah, they're great. I really do like their work.
Yeah, they did a whole series of virtual units too, just as an in the emergency of all their schools having to go to distance learning. So they have some nice resources there too. I don't think it's completely complete, but there are some good ideas in there as well. I find that whenever I read the paper or I'm walking around or anything I see, I'm always thinking, is this a phenomena that I could connect this to, this science concept or whatever. Once you start doing it, you start finding those connections. Just read the paper and you.
A lot of times too, oh, I'm sorry. A lot of times too, kids will bring in like videos, or you'll hear them talking about a video that just got posted about like the sunfish or whatever. And you can take off on that, or why there's a shark in Boston, because they see it online and they want to know about it.
Exactly. Yeah, and I just want to point out that as part of our planning guide, we actually have what we call a phenomena checklist. So what, criteria for what makes a good phenomenon. So even if you don't use the rest of this, planning guide for because you have a one that you already use, I think the phenomenon checklist is really useful to get you to think about, like, is that video a good thing I should use? Oh, okay, it does check all these boxes. It is something the kids are excited about, and I can relate it back to something local. So let's use it. So it's a good guiding tool. That again, I pulled from a lot of different sources and discussions with teachers, and that's how we ended up with our checklist for the UGC project. So
Cool.
Yeah.
all right. Anything else? Please be in touch. And yeah, enjoy the rest of your week.
Yeah, it's almost Friday.
It's almost Friday.
Hooray.
I'm gonna stop.